we go, another Monday. It's supposed to be nice weather this week, which will be good. Right, we've got new members. What have we got? I think the end of last week was Ramiro, Stephen, Peter and Tony. And we've now got Alan and, I can't never read my, Nigel. Sorry, Alan and Nigel, both UK. Welcome aboard. Okay, what's on the bench at the moment? I've got this thing. Several people, since last week's video, several people have said, can we have a look inside? It's not much of an effort to undo a couple of these bolts here. This lifts right back. So I thought, okay, I'll do a quick video and a few photos, because a lot of people remember these. They never actually owned one because they were very expensive, never seen inside one. So I've made a kind of a quick video clip. Have a look at this. Well, the motor's a bit slower. It needs a lot of work doing to it to make it work properly, but I'll have to help it to wind back if I can. There we are. I think the motors need oiling and things, and all the mechanical moving parts need cleaning and oiling. So let's just get this tape wound back to the beginning. It does go on its own, but it seems to slow down. The motor's not very good. Let's just take this off. That's it, stop that. What I'll do is I'll get another camera and show you close up of the inside. It's quite amazing in there, so hang on a minute. Okay, so I don't know whether you can see that sort of fan on it, that keeps it cool there. There's another motor there and another motor down there. One of the motors is a bit noisy. It was going psh, like that when it was working. So that's a big flywheel there. Someone's replaced some parts in here, which looks good. So someone has done some work on it. Then down the bottom, I'll show you down the bottom here, hang on. There we are, that's the amplifier in here and in here. You can't quite see. There's one of the valves there. Can you see that, one of the valves? A big transformer, capacitors, all the parts. This is really nice. These were very, very expensive. So there we are. I've put it back together, put the tape back on. So if we play that, there. I don't know what that dreadful music is. It's awful. There's the book all about it. So there we are. It's a nice machine. There's a couple of photos close up. It's a bit better than the video. Have a look at that. Now that's under the deck itself. As I said in the clip, 3 motors there, which was in its day, you know, that was amazing. 3 motors. Most tape recorders have 1 motor. A load of belts and idler wheels. You notice there's none of that. No belts, no idler wheels, none of that stuff. So there we are. There's another one down there. Yes, a very nice machine. I'm going to sell it because it's not mine. I'm going to sell it for this chap. I know I said last week I'm not going to get involved, but I shall be putting it on eBay, and we'll see what happens. Collection only, because it weighs an absolute ton. It really is heavy. You know, it's difficult to lift. One thing that's surprising, when were these? Were these late 50s, early 60s? I would have thought they'd have a couple of... There's one EL84. I thought they'd have a couple in push-pull. You know, that would have been nice, wouldn't it? Push-pull. It's mono, of course, not stereo. And it's only 2-track, not 4. But I thought they would, yeah, EF86, 3 of those, EL84, EZ80, ECC82, ECC83. You'd think that would have been push-pull. Nice big speaker in there, big, the elliptical one, only one that side. But there, I don't know when these were manufactured. Or I'm sure it was early 50s they started, and went into the 60s. I did, you know, I think I said last week, I have worked on these many decades ago. Don't remember much about them now. But there we are. Okay, let's move on. Thanks to Gordon for a link to a company that supplies resistors and capacitors. They're in America, but yeah, it doesn't take long to get stuff. The prices are pretty good, Gordon reckons. And I've had a look at the site, and it is interesting. All sorts of resistors, capacitors, all sorts of stuff like that. Certainly worth a look. I'm just gluing I'm not gluing a plug on. I'll tell you about it. I just put a little bit of araldite around the top there because this is this cotton cover type braid stuff on my Morse key there. Like I say, my new Morse key. It's not. It's 1950s. I've put the link on the other members' main page on the left there, where it's video news and all that. It's down the bottom. I think I've called it resistors and capacitors. So worth a look. Thanks to Gordon for that. What else was there? A few people have asked. You know, I've been talking about transformers, getting audio out of a valve via the transformer into a speaker, that sort of thing, plus mains transformers. I thought I'd covered this, but several of you have been asking after that one about in the transmitter at the broadcast station, the AM transmitter, how do you, to get the carrier, okay, you produce RF with an oscillator, you amplify it, you then amplify it again, you then put it into a big fat valve, the power amplifier, couple that to the aerial, that's the carrier. How do you modulate that? I'm just going to do a blackboard thing in a minute. It's similar to getting audio out of a valve, all right, your audio output valve through the transformer, but it's kind of back to front. And it's quite interesting the way it works. It's just like an output transformer. The modulation transformer is very similar to that, how it operates. I'll show you. I'll get the blackboard out. Just going to let this dry for a minute or two, and we'll have a look at that on the board. Okay, this is going to look a bit of a mess because it's a transmitter and an audio amplifier. Forget all this here for a minute. This is the audio output valve, forget this. Okay, audio output transformer and speaker. This is HT up here. Do you remember that? Okay, primary, secondary into the speaker. Right, what I'm going to do is, if I can find my rubber, I'm going to get rid of that. Okay, this is now a transmitter power amplifier stage, the final stage. That is an RF choke. What that does, okay, this is HT. This valve wants HT. This is the transmitter valve, the final valve. So you put HT onto there. This produces a lot of RF. Okay, this is our signal. You might have like 100 watts of RF coming out of here. You don't want that going onto your HT rail. So what you do is you put a fat RF choke in there. Okay, that allows DC through, but it won't allow RF back onto the HT line. You don't want that. This comes from a pre-amplifier stage, a buffer if you like, the oscillator. Okay, so you produce RF, say we're on 1 meg, middle of the medium wave band, you have an oscillator at 1 meg, you amplify it again, stick it into here. Normally the valve before that's called a driver. That drives this big valve. Okay, lots of RF, 100 watts of RF comes out of here. Okay, that capacitor. You've got HT here, remember, you might have thousands of volts. You don't want that going up the aerial. Okay, capacitor there. This depends on the transmitter, of course, a big broadcast transmitter. This will be a capacitor not at 400 volts like ours. This will be a capacitor at several thousand volts working, DC working. This is the tank coil, variable capacitor. This is the Pi network, they call that, which couples the valve here to the aerial. Okay, it takes RF from there to there. It matches the impedance from here to here. All right, and then RF goes up the aerial. So how that we've got a good strong carrier in the middle of the medium wave band. How are we going to put music or voice audio onto it? How do we modulate it? Right, that's what I'm going to show you next. Right, remember this board, okay? Now the HT here, there, doesn't just go to the power supply. I'm going to have to do another blackboard. I'll draw that and then I'll come back. We're now back to the audio amplifier. Okay, forget the other RF stage, the transmitter itself. This, a modulator, is an audio amplifier. Okay, so before here we got preamps and stuff, microphone in, from your studio, your audio out of the studio. Okay, goes in. I've just drawn this as a triode to make it simple. Okay, this is an audio output valve basically. And this transformer, normally you'd put your speaker here, wouldn't you? Okay, what you do this time, this here, this HT, we'll say that's 300 volts. Okay, right, here we have, this isn't an audio output transformer, this is a modulation transformer now. I mean, the audio amplifier is basically the same. The audio from the studio is amplified, right? This is the output valve and the transformer here, not to a speaker, but this time to a transformer with a lot more windings this side. Here you have your HT going in, HT positive, which might be 3000 volts. Okay, or I've written 30,000, but that'll do. Okay, 30,000 volts if it's a massive transmitter. All right, so that one, this goes through the RF choke, do you remember that? To the transmitter valve. Okay, so that's an ordinary audio amplifier. Instead of our speaker output transformer here, we have a different type of transformer, a modulation transformer, all highly insulated, of course. We won't have that at 30,000. Let's stick to 3,000. You know, we don't want lightning all going all over the place. Okay, so audio comes into here. Okay, no speaker, it just goes into this winding. As I said, do you remember last week, the AC, the current flowing through here is varying, and that causes a varying voltage in here. So what's happening? We're passing HT through that. What does that do to the HT? HT is normally, DC is normally, where can I draw it? A straight line, it's DC, isn't it? AC is like that. Okay, audio is, well, like, as you know, it's like that. Okay, so what this is doing, this is varying the HT to the valve, all right, with the audio. So that the valve is being fed with HT that's, how can I put this, kind of got audio superimposed onto it, if you like. Okay, that variation, the audio, the modulation, you know, up and down like this, that is appearing here. Okay, so you've got your carrier, which was just a, right, this is 1 meg, a 1 meg carrier, like that. It is now modulated like this. Have I drawn that properly? Okay, there's the audio. The audio is altering the amplitude of the carrier. Okay, and that is all done by passing the HT through that secondary winding there on the modulation transformer. RF choke to keep all this RF out of here, we don't want it up here. Okay, so that's our carrier. Put the audio on here, from here, okay, goes through here, and that's what it does to the carrier. It modulates the amplitude of the carrier, like that. And there it is. Basically, that's, as you can see, the modulator is an audio amplifier. This is the sort of arrangement you'd have in an amateur radio type transmitter. In a big transmitter, you would have here, for example, the audio, you'd have push-pull, okay, and you'd have big valves. Roughly speaking, in this setup, okay, I don't think this is used anymore. It's all, what is it now, phase modulation and all this modern nonsense. We don't all that stuff, all this modern stuff. But in this sort of setup, basically you needed half the audio power, half the transmitter power. 100 watt transmitter needs 50 watts of audio. So you've got to have a 50 watt amplifier here, a 50 watt audio amp. Obviously, you know, 500 watt transmitter, you need 250 watts of audio to modulate it. You know, so that's a lot. I mean, that's just a rough rule of thumb. Also here, the PA valve, this is anode modulation. The screen grid there, you very often have anode and screen, or as they call it in America, plate and screen mod. There are other types of modulation. There's series gate. I mean, if you're really interested, you can look all this up. There's series gate mod. There's you have control grid modulation, cathode modulation. There's all sorts. But this is the way most, in the early days of amateur radio, when I was a boy, this is the way that we used to build a AM transmitter. You know, bear in mind our transmitters were what, at the most sort of 50 watts here, so 25 watt audio amp. You never quite got that. You know, a couple of big fat valves in push pull, you might have 20 watts, but it was good enough. That is the part that's difficult to get hold of, the modulation transformer. I've got one somewhere down there, a big one, quite a big transformer. And it's really nice. I don't know what to do with it. It's worth quite a lot of money actually, because they're so rare these days. But so you can see what I said when this is kind of similar to the audio output stage, right? Your speaker would go there. Instead of that, you just pass the HT to the PA valve through that secondary, and it modulates the HT, and you end up with that. And then of course the receiving end, the radio, that's where we come in, that's where we do our work. It's demodulated. You take away that RF and that other half there, and you end up, there you are, there's your audio that we put in the first place from there, having gone possibly thousands of miles through the air, from aerial to aerial. It's all clever stuff. Going back to the transmitter, the PA stage, this is the HT, that would be our 3 kV, okay, from the modulation transformer. In an FM transmitter, this isn't modulated here, all right, but the oscillator down here, the oscillator is modulated, so the frequency varies, and by how much it varies is called the deviation. Okay, and you vary it so many kcs from the center. Okay, so the actual frequency changes. So when you get here, the amplitude, instead of that, as we had before, okay, the carrier is constant. There's the carrier that's constant, but the frequency varies like that. Okay, so you might get stretched out, deviates either side of the center. And of course that way you don't need any fat modulators or anything. You just need a small audio amp right down the oscillator end. With what we used to do in the old days is build a 10 watt transmitter. Okay, just a 10 watt transmitter, 5 watts of audio to modulate the 10 watts of RF. And then, if you wanted more power, build yourself a linear amplifier. I made one, it was, I forget the valve, grounded grid amp. Not very efficient. You need to put, I put 10 watts in to get 100 out. Was that right? I think something like that. So, yeah, it was, and being linear, so you can do your modulation down on your lower power, on your 10 watt transmitter. It's got to be a linear amp, because if it's not linear, it will distort everything. It will distort the modulation and everything. It's not just amplifying the carrier; it's amplifying the audio, the modulated carrier. So yeah, I used to have some fun with audio amps. The little 10 watt transmitter, and then build this huge thing just to get 100 watts. The one I've got it somewhere. I think it's partially in bits now. I think it would do 300 or 400 watts. But of course you've got to put quite a lot of power into it to get that out. So there we are, that's that. What else is it? I think that's about it, isn't it, on transmitters and modulation. Bit of a funny week again. We've had I've had a lot of estimates and I'm waiting. The lady with the DAC-10, you remember the DAC-10 in the end? She didn't want it done in the end. I did eventually hear from her, so that was that. I'm waiting to hear 3 other radios, so I can't get on with anything. There's a couple meant to be arriving in the post. They haven't turned up. I've taken my jacket off. It's getting warm now. The weather really is nice here in the UK on the south coast at the moment. It's Friday, by the way, so the week's almost gone. I've had to take my car in for MOT. All that's taken time. Went to my grandson's Easter bonnet parade. He's what, 3.5? Went to his Easter bonnet parade. That was a day virtually gone by messing around with all that. So yeah, one of those weeks. So a slightly shorter video. I won't end it just yet in case anything else crops up. But I think that's it for a minute. I shall go back out in the sunshine. I'm playing with aerials again. And for those interested, there will be added soon a video on learning Morse code. Okay, I did promise that, and I know a lot of people are interested. I have had quite a lot of feedback about that. Morse code, it is still used on the shortwave bands, not only by radio amateurs. There are other agencies, shall we call them, or whatever they are, using Morse code. It's quite interesting when you're writing it down. You're receiving Morse and writing it down, and you think, hang on, what's this? It doesn't make sense. Oh, it's German or whatever language, you know. Oh, I can't read that, but you've written it all down. So you're actually writing in German, which is, there we are. Anyway, I shall have a think and I'll be back in a minute. Well, I think that'll do for now. The video's not quite as long as it should be, but if you can hear that, it's like a compressor going out in the street now. I don't know what they're doing around here. Always digging up and drilling and whatever they do. So I will end the video here and I'll start on next week's one on Monday, of course. I don't know what's coming. Still got a clear bench. There's all sorts happening though. So I shall see you all next week. Thanks for watching as always. Bye bye for now.